Hello everybody, welcome to our course, and today we are going to consider the graphs, and the first lesson is introduction to graphs. The introduction we are going to start with undirected graph. Undirected graph. What is an undirected graph? The definition of undirected graph is very simple. It is a vertex. Vertices are which connected by edges. What is a vertex and what is the edge? Vertex, we can for example the vertex A, vertex B, vertex C, vertex D and vertex F. We can see the dots, just dots, which are given the letters A, B, C, D, F, and we can consider vertex, each vertex, as something from our real life. For example, each vertex we can consider as user, and the edges which connecting them as the internet. As you can see, if each vertex which given the letter we can consider as user of internet or one application, the edges which connected them shows that each user has contact to the second user, and there is lots of examples from real life which we can show you. For example, the streets of our city. For example, we have the streets like that, lots of streets by the y-axis and the streets by the x-axis, and each intersection we can consider as one vertex. There's lots of intersections, as you can see, and the streets which are connecting them as the edges. For example, the intersection of gives the name to the B street, and this is Sina street, the y-axis, and the intersections, the edge, the street, this is the edge connecting the two vertices. And we can show another example as a metro way, but the metro in Almaty is not so big to consider as the vertex and the edges, but we can do it. For example, there's a lot of stations like that, and if we consider each station as a one vertex and the way of them as the edge, it is also undirected graph. And what problems we can meet with the undirected graph? It's not actual problems, we can say it's as a challenges. What we want to know? We want to know is there like paths between the two vertices, between vertex A and B. We might want to know this, and we might to know the shortest path. What is the shortest path? And is there like how many vertices are connected to one vertex? And is there a path? Is there a cycle between in this graph, or like what is the Eulerian cycle, Hamilton cycle? And there's like lots of challenges, and we are going to study the next. And the next thing we are going to study is the DFS. As I said before, we can have some challenges. We might to know is there like a path between the vertex A and the vertex B, and we might to know the shortest path and something else. And the next thing we are going to study is DFS. DFS is a very old algorithm which helps us to find if there is paths between two vertices. Okay, let's draw a graph with vertices and connect them. Okay, now we have graph, and let's put here S and here target. What it means, we are going, it's our source vertex, and we are going to this target vertex. We want to find the path. Is there is like path here, and how DFS works. The DFS algorithm is working like that. It at first takes the source vertex and chooses the first way, goes on them, and continues doing this, like goes to the second vertex and finds takes the first way which have option and going to here and doing that, and he always marks the places where it has also always been, and DFS is not going to the vertex which he marked also. Now I will go to explain. We have source vertex and we are going to on this direction. We are here. Just put like that mark. Okay, we came to here and we mark this vertex. It's also marked. Its source vertex is also marked. And we have three options. We take first one. We are going to here. We are here. This vertex is also marked. And we have only one option, this source vertex. But the source vertex is also marked. And we are not going to the vertex which we marked. And we will come back to that place where we have another options. For example, on this example we have the options, another two options on this vertex, and we are coming back, and we are again here, and we are going to take the second option on this vertex. We came to here and we mark this vertex, and we are here now. We have two options. We'll go on first option. We mark here, we mark this vertex, and we are now here, and we have only one option from this vertex, and it is again source vertex, and it is also marked, and we are not going to on this place. We will come back to that place where we have option another, and this is here because we have another option and the second option, and we are going to on this place. Oh, fantastic, it's our target here, and it shows that the path must be like this according to our DFS algorithm, and we mark it this vertex, this vertex, this vertex, this vertex, this vertex, and this vertex. Yeah, it how works DFS algorithm. It is not the fastest algorithm, but as you can see, it works. It is a very old algorithm. The first it used by the legend by the Zeus to kill the Minotaur, and he went in the maze, and some people said him to not be lost in maze, just mark the places where you have also been, and the DFS algorithm is an example of this. And what we use on the DFS algorithm, here we are using the two data structures. It's a market array, it is Boolean, and the edge 2 array, it is integer. What is going to market array do for us? We just there is a value true or false. True or false. False means that it is unmarked. True means that it is marked. Edge 2, here we are going to write the vertex on the vertex, the one hop before, from which vertex we are going to come to this vertex. For example, if we are going to take the target as our target, and the edge 2 must be this vertex, because we have edge from this vertex to this vertex. And how we are going to consider it? Edge 2 at target is going to be this vertex. Just give some A, B, C, D, and the edge 2 of target is going to be C, this vertex. And also the edge 2 of C is going to be the A, and the edge 2 of A going to be the source vertex here. Let's consider the code of DFS on Java code. Here we have the class DFS, and as I said before, we have two data structures. It's a market boolean array and the edge 2 integer array. I said you about the functions, how they are working, and we have the integer source. It's a vertex source, and we have constructor. How constructor is working? Here it just calls a DFS method, which we have here, private void DFS method. How DFS works? It is recursively calls the DFS method, which takes the graph and the integer v. V is the current vertex where we are. In the constructor, we call it the DFS method first time with the vertex source, which we are starting. And here, how DFS method works? It takes a G graph and a V integer. It marks true the vertex, and it is checking from adjacency. It is a list from graph API where we have the all vertices which connected. It checks if market, if not market. It calls the DFS method to the next vertex which connected to vertex V recursively, and gives to edge 2 array his vertex that to go to vertex W you will go through the vertex V, and it comes to again to the next vertex W. It again becomes V and it marks it again, and from adjacency list it looks for not marked vertexes which connected. And when this DFS recursive method stops, when there is no choices which are not marked, at this moment the DFS stops. He marked all vertexes and he found all paths, and there is nothing to do more.
Okay, next we are going to talk about BFS, which is another way to process all the vertices that are connected to the given vertex. So, to simply understand what is going on, we are going to start with an example. So, the BFS is not recursive algorithm. That uses Q as an auxiliary data structure. So let's start to see what is going on with an example. Firstly, we put a source vertex to our queue. Here, we will start with 0. We put it, and then we dequeue it from the queue and enqueue all adjacent vertices to 0, to the source, and queue it to the queue 2, 1 and 5. Yes, and here we have also another data structures as H2 and these two. H2 shows us from which vertex the previous vertex came. For example, from 0, we just started from 0, so we don't have edge 2. 2, it shows from the 0, it came from 0, and 1 also, and 5. This 2 shows how many edges we have to that vertex. 1, 1, and also 1. So now all these vertices are marked. This, and this. So we continue with the queue, with our queue. We dequeue our first element that came into queue. It's 2. Then we put all adjacent vertices to the queue. 3 and 4. And here we have to 3 we came from 2, and to 4 also we came from 2. And here we have distance like with 2 edges. And we repeat all these actions till our queue is not empty. So then we go to 1, check its adjacent vertices is 0 and 2, but 0 is already marked, 2 already marked. Then we just dequeue, and then we check with dequeue 5, check it adjacent vertices 3 and 0. It's already marked. We forget to mark it. Yes. Then we continue with 3. 3 is already marked with 2, 4 and 5, and 4 already marked 3 and 2. So here the queue is empty now, and this is how the BFS works. Okay, for what do we need this BFS algorithm? The very important usage of it is finding the shortest path. Okay, let's go to the code. Okay, here is the code of breadth first search. As you see, we use marked boolean array, h2 integer array, this2 integer array, and that's all. But this three data structures that we're using in the BFS. Okay, here we have a method BFS which takes graph G and integer source. We initiate a queue which filled with integers, and as I told before, firstly we enqueue the source to our queue, and we set that it's marked like we visited it, and distance to S we have 0. Then we open the while queue is not empty. Integer v is the integer which is dequeued from the queue, our source vertex. And in the for we have our if condition. When if it is not marked, we enqueue it in the all queue, in our queue. Then we mark this as a true. H to v, h to w, it's v, and distance to w is incrementing by 1. And this is our algorithm repeating while our queue is not empty, and time proportional to e plus v. So for what we use breadth first search, very important implementation of BFS is shortest path. Okay, here is an example of BFS. It's an old application for routing. In computer networks, it's very important when you are communicating from one place to another place, and it's very important to get from here to here in the fewest number of hops. In past, we had very slow computers, as you know, and BFS helped to find the shortest path to the target from the source. And that's all. Next topic will be about connected components.
Okay, our next topic is connected components. Idea of connected components is that if they pass between two vertices, we say they are connected. Like in example, here example of undirected graph. There is 3 connected components: first, second, and third one. Here is example of undirected graph. We will start from 0, and we need to go through adjacent list of 0. At first we need to mark, and after that we will go to 6 and mark it 2. And like in DFS, we will go through graph. After that we'll go to 4. We need to write here 0, and here 0 is the count of connected components. After that we go to 4 and mark 8. Here 0, and so on. 3, 0, and after that we will done this DFS with subgraph. We will go to we will check, start from 0, 1, 2, 3, and we will look to mark it or not. If it's not marked, like 7, here we'll start from them, mark it as true, and here we will write 1 because it's the second connected component. Here is example. Here is a code of connected components, and we have array of boolean marked like in DFS and BFS, and we have array of integers ID. We use it for ID of connected components, like here, and we have array of integer size and count. Here we create arrays with size of vertices. After that we open for, and we go through all vertices, and here we check marked it or not. If it's not marked, we are going to DFS. It's a typical DFS, but here we add ID with a count and size. After our DFS was done, we go here, and our count will increase for 1, and again for 4, and so. Next will be exercise for you for these topics.
So okay guys, let's start. Let's end our topic with the assignment. So in the beginning I want to start off with a review of application of DFS and BFS. So applications of DFS is detecting cycle in a graph, path finding, topological sorting, finding strongly connected components of a graph, and solving puzzles with only one solution. And review of applications of BFS is shortest path and minimum spanning tree, peer-to-peer network, crawlers in search engines, so social network websites, and Ford-Fulkerson algorithm. So our assignment name is Mutable Friends. So I think everybody in our century faces with this problem. It's like, for example, you want to be friend with somebody, and you want to find shortest way to write to him by your friends. So our format of task will be input is a file txt, and output should be string format. So format of txt file. So first line should be integer, counts of people in social network. Second line should be integer, count of people that are friend. And next should be n lines with name, surname, and ID, like Undasından Muhammad with some ID. And m lines should be how people are connected by their ID. So here is it. So example, here you can see like 5 is a count of all people in the network, and 6 is like connected persons. So and format of output should be name and surname of person 1, name of surname and of person 2, and etc. like till end. So short space. So where S is a starting person who finding a way to be friend with E, and E it's a person who wants to find S. So here is the shortest space example, so output example. So for example, to write Din Muhammad to Gulshat teacher, Din Muhammad should write to Anel, and from Anel he should write to Gulshat teacher. So it's a shortest path of our graph. Grading policy. Grading policy of this task should be like for brute force it's less than 65 points persons, and with algorithms grade should be some better than 65, and none should be 0. Some things that may help you with solve this problem is dictionary. You can use some dictionary, BST, DFS or BFS, Q, and back. So that's all. And if you have any question, you can write to these emails. Any question about this task? So that's all. And we will show you answer for this task in the link of our video. So thank you for watching.